Hi everyone. Today this is my very first IB videos. I've done quite a few for my VCE classes at my previous school. Then let's start. Hopefully it works out well. And today there's a topics that we're going through in class. It's called limited reagents. I'd like to use one example today to go through this particular concept. The example that I use is salt with silver nitrate. This is a very typical chemical reactions. As silver nitrate, the silver ions is going to react with the chloride ions, and when they react, a precipitate forms silver chloride, and then we find out a sodium nitrate we still add as an aqueous form and dissolve in the solutions. When you have this reaction take place, we notice one thing will react with the others. But the question we'd like to look at is, if I give you two different masses of the chemicals, which one would be the limited? Saying, if I say I give you 5 grams, should I say that one would be 2 grams of sodium chloride, and then I've got 5 grams of silver nitrate. And it's quite misleading by looking at the mass there, 5 grams and 2 grams. You may say that, okay, my sodium chloride would be the limited reagent because there's less mass. But in chemistry, it's always not that simple, right? Mass is always quite misleading. Then we need to find a way to actually completely saying that which one is limited, which one is in excess. Then a school geometry come in. What we do for school geometry for the very first steps, always look at our mole ratios. The mole ratios basically means to look at the coefficients of each reactant first. The coefficient for sodium chloride is 1, and the coefficient for silver nitrate is 1. As this is 1-to-1 ratio, literally actually means that 1 mole of our sodium chloride is going to react with 1 mole of our silver nitrate. It also means that if you have 2,000 moles of sodium chloride, it will react completely with 2,000 moles of silver nitrate. It won't react with 2001. It's exactly 1-to-1 ratios. Then, once we find out this 1-to-1 ratio, the second thing that we do is, as mass is not quite honest and it's always lie to us, and we're going to convert that into a more honest figures, which is our number of mole. If we need to convert sodium chloride into number of mole, NaCl, then the formula that we need to use would be mass over molar mass. The mass that we have for sodium chloride is 2 grams, and the molar mass for that is 23 plus 35.5 from the periodic tables. We've got 2 grams over, if you add those up, molar mass for that would be 58.5 grams per mole. Then we find out that the number of mole for 2 grams of sodium chloride is 0.0341 mole, right? That is the amount that we have in terms of the amount of NaCl. Then we need to compare the amount of the sodium nitrate. Also looking at this mass over molar mass, we've got 5 grams this time. 5 grams over silver nitrate is pretty big molecules. Silver is 177.9 plus 14 plus 16 times 3. That's gram per mole. If we're looking at that, it's 5 over 169.9. Then we've got the answer is 0.0294 mole. Now we have 2 values. Which one is limited now? We can see a smaller values is actually coming from the AgNO3. And we come to a conclusions that our silver nitrate is actually the limited reagents, not the sodium chloride. And sodium chloride is what we call in excess. So hopefully it helps you to understand a bit better. I'll give you a bit more example for some other videos. Thank you for listening. See you.